Now I feel like I should have prepared a different talk about pastries. Okay, so as you've heard, my name is Giacomo. Today I will be talking about not Gleam, even though I do quite like the language and I will be using that. I will be talking about my favorite testing technique, and that is snapshot testing. But before we get into that, allow me to set the scene. So let's take a step back. I think we can all agree that we do need tests, and it doesn't really matter the language we're using, whether it is dynamically typed or statically typed. We still do need tests to make sure that our code behaves the way we want it to, and also to have the confidence to move things around, to do big sweeping changes to our code base, and rest assured that if something changes unexpectedly, well, it's not going to blow up, or at least it's going to be much harder for bugs to sneak into our code base. The problem is that sometimes, or well, if you're like me most of the times, writing tests can be quite boring. It feels like a chore. We don't want to be doing that. We want to be writing the fun algorithmic stuff, not tests. And okay, so all the examples are going to be in Gleam. I'm biased, I quite like the language, but hopefully the syntax is friendly enough that you can have a good grasp of what is going on here, even if you've never written a single line of Gleam before. So here we are defining the simplest possible test there is. We are saying that 1 + 1 should equal 2. That should.equal is calling the equal function from the should module. If you're the Erlang inclined, that would be a column. Here it's just a dot. And Gleam also has a nice piece of syntactic sugar I'm going to be using throughout the slides that makes writing and reading this kind of code a bit nicer. That is the pipe operator. Basically what it's doing is taking what comes before it and passing it as the first argument of the function. So this reads nicer, almost like an English sentence, 1 + 1 should equal 2. And I think it's a bit nicer to read. So we can run our tests, Gleam test, everything is fine, math isn't broken, and we are fine. But if something is wrong, well, the test runner is going to tell us, and then we can go and fix our test and go on with our lives and finally focus on things that we find interesting, not tests. Well, the problem is that we wish that writing tests was this simple in the real world. Well, it's not usually just as simple as writing 1 + 1 should equal 2. So let's look at an example that is just a bit more involved to show some of the shortcomings of this way of writing tests. Let's say we're writing a CLI application, and maybe we are auto-generating the command line help text. And that comes from some kind of DSL, and then it's doing all sort of stuff and generating this help text. And we want to be testing that that is exactly how we want it to look like. I'd argue that this is the most important part of your application, and you should be testing it, because it is what people are going to be looking at when they don't know what to do. And so here, if you're writing the simplest kind of unit test, well, what you have to do is you have to write down that expected string. And you know that things start going wrong when the code doesn't fit in the slide anymore. So here you have to write down that string you're expecting to see. And no one wants to be doing that because that is a boring chore. I don't want to sit down and write that. So what does happen usually? Well, one might run the test the first time, putting an empty string there. The test runner complains. You copy the string you get from the output and you paste it there. It doesn't really feel good. Oh, I see some clapping. Nice. Or you might start doing something that I feel is even worse. That is, you start implementing some logic in your test to auto-generate the expected value. But now you're no longer actually testing that it looks exactly like this, but you're testing that your test implementation mirrors the business implementation, and that usually leads to all sorts of problems. But let's say, for the sake of the example, I've been a good developer. So I've written all those expected values with a lot of teeth grinding, and now the help text changes. Someone complained that it wasn't clear enough, or maybe we've added new options. Whatever that might be, that is a wanted change. It's not a bug in our code. What happens now? Well, we have loads of failing tests, and I need to go and fix all of those. I need to go find the strings or lists or dictionaries, whatever that might be, and type in the new expected value. If writing it the first time was boring, a tedious job, well, this is even worse because it's also error-prone. Let's say we make a typo fixing it. Now the test is failing again, and we need to figure out that the problem is actually in the test value and not in our business logic. So how can we make life for ourselves easier here? How can we make writing tests a bit nicer, to have a better developer experience? Well, if you've read the title of the talk, you know where I'm going. The solution is snapshot testing. So, what can snapshot testing do for you? Well, on the surface, it sounds a bit too good to be true. Basically, a snapshot testing library can take care of all those expected values automatically for you, with little to no effort, basically, from your part, and doing all the checking and keeping track of the value automatically. That sounds a bit magical, so I think that a code snippet here is worth 1,000 words, so let's have a look at some code. This is what we would have written previously, and this is what it looks like using a snapshot testing library. Here, the library I'm using is Birdie. I'm the author of the library, and it looks a bit magical, so let's go over it line by line. So we are still producing the help text. There's no escaping it. We need to be testing that. But now, instead of feeding it into a should equal function, we're asking the snapshot testing library to produce a snapshot, whatever that means, we'll get to it later, and also giving the snapshot a title that's used to identify it. Still, the first time I found out about snapshot testing and I read a snapshot test, I was like, how does this actually work? This looks magical. How can the library know that the value that should be produced by the function? Of course, it cannot read your mind. I'm not that good a developer. Maybe Birdie v2 will have some mind-reading capabilities, but for now, you can be safe that it's not doing anything strange. So it's time for something a bit scary for me. That is, oh well, okay, no. If you run the test, the thing is, it's just going to fail, which is not quite useful for a testing tool. So we are stuck in the red of the red-green refactor cycle. How can we move forward? Well, the nice thing is you're not only getting this failing test, which would be quite useless, you're also getting a nice output box with the content of the function we were testing and the title of the snapshot. And now it's telling us something. You should run the Gleam run Birdie command to review the snapshots. Aha, so a human needs to be in the loop. So someone needs to be reviewing the snapshots. So I think maybe you might have an idea of what is going on here, but I think it's now time for something a bit scary, that is a live demo. So here I have my tests. Is the font good, or should I make it bigger? Okay, it's good. So if we run our test, Gleam test, you see it's failing. You can see the output of the function, so you can already have an idea if it is what you were looking for. And now let's do what the library is asking us to do. So Gleam run Birdie. And now we are presented with all these snapshots one by one, so we can review those and decide if it's good and we should accept it, or if it's wrong, there's a bug in our code. We don't want that, we need to reject it and go fix our code before we can move forward. So if this is good, we can just accept it. And now every time we run Gleam test again, this is where the magic happens. It's always going to be green as long as the function we're testing produces the same output. And the idea on the surface is pretty straightforward. Basically, the snapshot testing library is saving these strings to files, and then it's checking every time you run your test that it is exactly what it should look like. What you said was the accepted value. But that might be a bit of underwhelming. So what it's actually doing is a lot more. It can make our developer experience a lot better here, especially if maintaining the test and evolving those over time starts getting like a chore. So what happens if we change our help text? So we move to a v2, which produces a different output. And now if we run Gleam test, what we're going to see is a nice diff view of exactly what has changed. So we see that in the first line we've added a new subtitle, we've added something more to the description and removed the file option. And I think this is quite nice because we don't have to learn anything new. We are already used to version control systems where things change and we look at diffs, we see if they are correct or not, and then accept it, reject it, go fix our code and move forward. So this is quite a nice developer experience. Remember, the thing you had to do before was go and change your string by hand in the code and figure out what had changed and how to fix it. Now the library is taking care of that and showing you exactly what has changed. And so the developer experience is quite nice here. So we can just review again. So we see that it is correct, we accept it, and then we're good to go. Every time we run our test, it's just going to be green. Whew, now that the live demo is over, I can finally take a breath. Okay, so cool. Maybe I've convinced some of you that snapshot testing is quite cool and you might want to start using in your code base. But if you start using for something that is even a slightly bit more complex than the example I showed you, you would soon run into a wall. And why is that? Well, maybe you want to try using it with a list, a dictionary, a tuple, whatever that might be, something that has a bit more structure than just a simple string. And the thing you'll notice is that the compiler will complain about it. You're trying to feed the birdie snap function a JSON, but it actually wanted a string. So what should you do if your data is not a string? If you want your snapshot testing to be working with a list, with a dictionary, a custom type, Gleam has custom types. Well, the answer is turn it into one. It might not be totally satisfying, we'll get to it. But here, for example, what we need to do is add another step to this pipeline. And first, turn the JSON into a string so that it can finally be fed into the snapshot testing function. And the knee-jerk reaction I usually get from people when I tell them this is, wait, really, do I really have to turn off my data into strings explicitly? So do I really have to define this toString function before I can use my snapshot testing tool? Well, the answer, again, is yes, but that's a good thing, actually, so hang in there. Then here, Birdie's API was really inspired by Gleam's own philosophy of being explicit and really hard to mess things up inadvertently. So it's impossible to mess it up. There's no magic whatsoever to Birdie's API. It takes in a string, and that is exactly what you're going to be seeing in your snapshot byte by byte. It's not going to try and implement some kind of one-size-fits-all string wrangling algorithm that can turn any data into a string, but instead it leaves you, the developer, in control of choosing the best way to present your data in a snapshot. Because while magic might be nice, the bad thing is that as soon as you start running into problems or the one-size-fits-all algorithm doesn't work, well, the magic disappears. So here we want to make the best thing like the only thing you can do. So it won't save you typing. You'll have to type just a bit more, write that toString function, but in exchange you'll get a much better developer experience. The idea here is that you want to be really intentional about the look of your snapshot, to make the snapshot testing developer experience better. And I want to show you just a couple examples of what that looks like in practice. So this example comes directly from Gleam's language server. The Gleam codebase uses loads of snapshot tests. I counted those the other day, and it's 1,800 snapshot tests, so it's quite a lot. And these examples come from Gleam's codebase. Basically, we are testing the language server. So Gleam has a pretty nice language server. It has loads of features now. And one nice thing it does is if you hover with your cursor over a variable, it's going to highlight the entire variable and then show you a nice little box with the type of the thing, so you can get a good idea of what's the shape of the data you're dealing with. So for example, here, if we are hovering over the Weeble variable, we want to see the entire variable to be highlighted and then to see int to tell us that that is an integer. I mean, in this example, it's pretty straightforward. We see the 11 is there, but usually it might be something that comes from a long chain of function calls. And how would you test this? Well, the language server is quite a beast. It's really hard to test it. It sends you messages. And the first thing we did in Gleam's codebase was just default print the response from the server and put that inside a snapshot. And so what one had to do was read it, see that it is correct, and then accept or reject the snapshot. So for example, here, well, the range, the thing you see there, is basically the highlighted bit of your code. And so what one has to do is, okay, so byte 24 to byte 29 are going to be highlighted, and you need to figure out that those bytes are the Weeble variable. And if you go see in that code, that is actually correct. So Weeble is from byte 24 to byte 29. And then you get the contents of the snapshot, that is a markdown string with a type. that is int. So this is actually correct, but would you be happy reviewing this kind of tests? Well, not really. You have to go and count the bytes in the string. That's not really something one wants to do. Again, it's tedious, it's error-prone. So what I wanted to do was improve the look of the snapshot to make it so that reviewing it was as simple as possible. And the visualization I came up with by being a bit more intentional and explicit about turning the data into a string instead of just accepting the one-size-fits-all solution was this. And I think that everyone can just look at it and in an instant understand that this is correct. You see the Weeble variable that is highlighted, and the over content is a markdown pretty printed string with an integer inside. So being intentional about the look of your snapshots is actually the right thing to do. And I wanted to encourage that through Birdie's API. So instead of just accepting any kind of data, I'm really explicit about accepting just a string. So that if your data is not a string, but some kind of strange response coming from a language server, some user data, something else entirely, you'll have to think about the best way to turn that into a snapshot. And I can guarantee you, if you don't trust me, ask Louis, how much time this has saved us testing the Gleam compiler. Because just by looking at it, even if you're reviewing code that is contributed by other people, you can look at it and see that it is correct at a glance, instead of going over bytes. No one wants to do that. Another example comes from Luster. So Haley had to write some front-end things like interpolation functions to do CSS animations. I really don't understand what that is. But basically, what that is a function that takes in 3 floating point numbers and spits out another floating point number, basically interpolating that point between two extremes, two values. And that is fine and all. You can look up the implementations and then implement it. And how do you check that those are correct, that you haven't messed up the math? Because it's easy to get a sign wrong, to do something that you weren't supposed to do. Well, if you're writing a unit test, prepare for a lot of pain, because you have to write something that looks a bit like this. So you're testing your function from the 0 to 5. If you're interpolating 0, you get something that is close to 0. We can just say that it's equal because it's floating points. From 0 to 5, 1, you get 1.2. From 0 to 5, if you interpolate 2, you get 2.3. And those numbers I put there are completely random, but you wouldn't have guessed. How could you tell that those are wrong? And so if you're reviewing this kind of code, what you have to do is, like with pen and paper, write down the expected values and do the math yourself to figure out if it is correct, or trust the developer who wrote it that they knew what they were doing and that the code is presumably okay. What Haley came up with, and it really blew my mind, is instead she took that tweening function, that interpolation function, and produced a plot out of it, and then put that plot into a snapshot. And so now, just by looking at it, you can see that is a cubic function that has is in and is out. And so I think that is so cool, because now you can just, by looking at it, and we humans are really good at spotting patterns, you can just see that that is correct. And so this has saved us loads of time in testing it. We don't have to go through lists of floating point numbers trying to figure out what was going on there and doing the math on pen and paper, or just trust someone. We can look at a graph and see that that is correct. Cool. So maybe you're already starting to think of places in your code base where snapshot testing could be fun, could be a good fit. There's other things I'd like to touch upon here, because knowing like snapshot testing, well, you can produce a snapshot, you're good to go. There's other things on the outskirts of this whole idea that you need to know to have a good time, besides making your snapshot look pretty. So how do we do effective snapshot testing? Well, first of all, write long descriptive titles. That's one thing that's really useful, because the title is the first thing you see when you are reviewing a snapshot. And if you're reviewing a snapshot and you see CLI test, oh, that is not really useful, isn't it? Now, how do you know what you're looking at there is the correct thing? It's quite hard. Instead, if it said, well, it has a clear introductory explanation and da-da-da-da-da, now you know what to look for. And you know that if the description, the introduction is not there, that is wrong, and you need to go and fix it. So Using a long descriptive title not only helps you, the creator of the snapshot, but also other people who have to review the snapshot, because then they won't have to go back and forth from the test code to the snapshot to the test code back and forth. Second point, keep your snapshot small. It's simple with unit test. It's in the name. It's a unit. It's small. It's self-contained. It shouldn't depend on some global state so that you can run those independently. And the same goes exactly for snapshot testing. So those should be small, self-contained, not depend on global external data that can change. And why is that? Well, for the same reason that you feel a sense of dread and pain when someone makes a pull request with 100 files that have changed at 1,000 lines of diff. No one wants to be reading that kind of pull request and reviewing it. The same goes for snapshots. If you have a snapshot that is 1,000 lines long, you need to go through all the 1,000 lines and keep all those things in your head, like, okay, now I will need to check for this and for that. Wait, did this happen? Did I find this in the snapshot? And so on. That is quite painful. So if your snapshot is 10 lines long, that's great. 100 lines long, maybe that's good. If it starts getting longer, maybe that's a good sign that you need to be splitting your snapshot into multiple snapshots. Or maybe that you can change your toString function to make that more focused, to focus on some specific aspects, because maybe you're testing too many things in a single assertion. And then don't overdo it. It's important to know when to use something, and when we learn something new and exciting, we want to use it everywhere. But the snapshot testing is not a silver bullet. I would never dream to write a snapshot test that 1 + 1 should equal 2. We have regular assertions for that. Where snapshot testing really shines, as I've showed you, is where just by looking at something, we can tell that that is correct. And writing the equivalent assertions would be a pain, not only to write it the first time, but to maintain it over time. If we have structured data that changes frequently over time, and maintaining it, changing it, is a boring, tedious, error-prone job that no one wants to do, to the point that people just don't run tests, well, maybe you could try snapshot testing to make things easier, because it's easier for a human being to look at something and see, well, that is correct, go on. And finally, version control your snapshots. So, snapshots are just as important as your regular code. They're part of your code base, just like the expected value you would have written was part of your code base, snapshots are. And snapshots are just files that the snapshot testing library you're using, not just Birdie, saves to the disk in your project directory. And you need to be tracking those. First of all, well, it's a must, because then if you run your test in CI, they won't fail, asking for a snapshot to review it, because it knows that the snapshot is there. And then you want to keep track of it, because it's a fundamental part of your system. It's like your golden values, the things you're expecting to see. And sometimes you'll hear snapshot testing referred to as golden value testing or something. So I'd like to close on more a personal note here, because this was really my first open source project that was actually used by people, and that was really exciting. I never did any open source before I got into Gleam, so thanks, Louis, for that. What did I learn? Well, I had to unlearn loads of things coming from university, and first of all, never give anything for granted when you're dealing with other developers. So, for example, how can I make the developer experience here as good as possible? Again, I want to replace some boring tests that are hard to review and to maintain with something that is more straightforward, that doesn't take you loads of time to review. And so, if someone runs Gleam test and the test is failing, how do they know that they need to review the snapshots? How do they know how to move forward? Well, that's what that little hint is there for. Because someone now knows that they need to run that command. They don't have to rely on the documentation. It doesn't matter how much care and effort you put into your documentation. No one is going to read it. And I mean, and I can't really blame them for doing that. I mean, people are in a rush, people have deadlines, or people are just excited to use your thing. They don't want to read through paragraphs of text to just start doing something, and then they will start doing something even if they haven't read every nook and cranny of your documentation. So we should try to make things easier for everyone, not just someone who has the time to read tens of pages of documentation. And so here the little hint telling you what to do next so that you are not stuck. Another one, does the package help me avoid common foot guns? And this was really a surprise for me. I might have gone over that a bit quickly, but titles are used to identify snapshots. What happens if you use the same title twice, then for different snapshots? Well, the thing is, you start getting mysterious failures. Your tests are going to be always failing because a snapshot overrides the other, and things are quite painful to debug if you don't know it. But as the author of the library and a snapshot testing enthusiast, I knew what I had to do. I just avoided using the same title twice. So I'm quite happy. I publish my package, people start using it, and then someone starts complaining. They're like, why are my tests failing? I have no idea what is wrong here. It just keeps on failing even if I review it. And it was because, and I could see that at a glance, they were using the same title twice. And I was like, well, it was in the documentation. So how did you not figure that out? Again, I cannot blame them. They really were into snapshot testing and wanted to do it. And so, listening to their feedback, it could be easy to dismiss people just saying, read the documentation. That's not usually the best thing to do. So I listened to their feedback and implemented additional checks that now at runtime, when you're reviewing your snapshot, make sure that you're not using the same title twice. And so it's telling you exactly why that is wrong, where it is wrong, so you can go and fix your testing functions. And I think this has proved to provide a better developer experience for everyone, not just that developer that was having issues, because then I didn't hear any more complaints because this kind of problem was completely removed from the library. And I think that just by listening to this person's feedback and not just dismissing it by saying you should have read the documentation, it was there, I think I came up with something that is way better for everyone and makes the developer experience better for everyone. I think it can be summed up with this. We're not good judges of the software we're writing. We are library authors. We are package authors. We know how that works. So we are not reliable when evaluating the usability, the quality of our code, because we know the ins and outs of the thing we are working with. And so listening to other people's feedback when we publish our code, it's super valuable and can help not only make our life easier because I stop getting complaints about the tests failing randomly, but it makes the life of everyone easier. So I think it's time to wrap up. Snapshot testing. It's a super cool testing technique. And believe me when I say that I think it really should be the default for many, many cases. And it has saved us, in the Gleam compiler, for example, so much time reviewing and maintaining all those tests with the generated code, with the language server, which is a piece of software that is quite hard to test. By making it something that is just as simple to review as looking at it and seeing that that is correct, of course it takes some time, but it has saved us in the long run so much time. And as I've told you, when I started preparing this presentation, the Gleam compiler had 1,000 snapshot tests, and now it has 1,800 snapshot tests, so it just keeps growing. And if you need assurance that it can work in a big code base, well, there it is. So hopefully some of you today will have discovered something new and exciting, and they will try to use snapshot testing in the code base maybe, or you're already thinking of places where that is really a nice fit and that could make your testing life easier. If you do that, please keep in touch. I would love to hear your stories about snapshot testing and or your examples. Again, that cool cubic wave, I would have never discovered that if it wasn't for Haley, who reached out and told me she was doing this. So please keep in touch if you think this is cool. If you want to talk about anything, really, you will find me on social media, on Gleam's Discord, wherever that might be. So this was Supercharge Your Tests with snapshot testing. My name is Giacomo. I thank you so much for coming here today.
Yeah, definitely thank you as well for this inspiration. So do we have any questions in the room? We do already. Okay, cool.
Hello. Would you consider using images as part of like snapshot testing for things like rendering HTML pages or something like that, or would that be something you would consider adding in the future?
There's people who definitely do that. Like in the JavaScript world, it's pretty much common to do snapshot testing for web pages visually. Um, in Gleam, I've never seen that. I've seen people doing that with the raw HTML, not just the rendered page, because that adds loads more of complications. I don't know if that's something that people feel like would be a nice addition, but it's really complex, so I'm not really sure at the moment where this will go.
Okay.
Hi. First of all, thanks for the great talk.
Thank you.
So I was just wondering, like, do you have any numbers or have you profiled the impact of using this? I'm just thinking because of the, the inherent impact of like using those files and reading those files in terms of like running the test suite for Gleam with and without snapshots in terms of like speed and.
No, I haven't. Maybe Louis can weigh in on that later if you.
We did a big migration, moving all of those from example tests to snapshot tests, and there was no noticeable difference between it.
All right. More questions? Yes.
Yeah, great, great talk. I was wondering what you use to test your pretty print functions. Do you snapshot test those, or unit test them, or just leave them?
I don't. I usually when I look at the code and it has a funky look, I usually my debugging goes, well, is something wrong with the pretty printing function? Or is something wrong with my data? Usually I have a look at the pretty printing function, and most of the times it's pretty straightforward to figure out if you're doing something wrong with the formatting of the data or if with your business logic itself, and then you go and fix it. But I usually, don't test the pretty printing function itself because it's already in the snapshot, and you see if that is right or not, the look you wanted or not.
Cool, thanks.
All right. We have time for some more questions. I have one on the Hua app, and the question is: do you have an example of a snapshot file?
Yeah.
So
I can show you the one from the live demo. So here you have a directory with all your snapshots, and this is the snapshot file. So it has a little bit of metadata, the version of the library, the title, the file where it comes from, the name of the test function that defined it, and then the content of the snapshot. So it's pretty straightforward.
nice. So this is, I'm guessing this is Markdown or
It's
format?
yeah.
Something similar. Okay. All right. One more question. And this will be the final one.
I was just wondering if you had any plans for dealing with inconsistencies in the snapshots. But one of the problems with using it is like if you have, say, a line number changing in a file output that is not consistent, the snapshot is technically the same, even though it's like an off by one error.
I'm not sure I get the question. Maybe.
So if you have a snapshot that's, say, an output of documentation from something, and it includes a code line number,
Oh,
and
I
you
see.
change
Okay.
a line number,
Okay.
the output's still technically the same, but one thing has changed. It's
Yep.
not actually relevant to whether the code has done its job or not.
Okay, thank you. Yeah, that's a good question. I had a problem with that. I was snapshot testing one of my other projects, and the output included a version number. So every time I updated my version, I had to review the snapshot once again. The way to deal with it is just usually change your pretty printing function in a way that makes sure that you don't include that kind of data in your snapshot. So what I had to do was change the way it worked, make the version actually a parameter of the function I was testing, and then pass in a placeholder value that I could make sure is always the same. So that led to a bit of change in my code, and I think that was for the better though, because now I can deal with that more easily, even in other places where I was having troubles, and the snapshot changing just highlighted that kind of problem I had in my original code. So usually the way to go is you have to work a way to not include that kind of variable data that is just noise to your test.
All right.